Hi explorers, nice of you to drop by. I've got a super cool experiment for you. Before we get to the experiment, take a second to subscribe to Clayton's Exploration Station so you don't miss any fun in the lab. Plus, there are some links in the video description to help you follow our social media adventures as well. In this experiment, we're going to use ice and rock salt to create a supercooling solution to help us lower the temperature of a bottle of water beyond its normal freezing temperature. This is called freezing point depression. We can then force the water to release all of its heat energy and freeze on the spot while we watch. To do this experiment, we need ice, a thermometer to monitor the temperature, rock salt, which is commonly used on sidewalks during the winter to keep ice from forming, and 2 bottles of water. These should be plastic, not glass, because you are going to be knocking it on a surface and you don't want it to break, and they should still be sealed. We start by cooling our water. You can get a head start on the experiment by leaving your bottles in the refrigerator before you do the experiment. We take our bottles, put them in our great big bowl, and then we're going to surround them with ice. We've surrounded our bottles of water with ice. Now we're going to put our thermometer in so we can monitor the temperature as we wait. Next, you're going to sprinkle a generous amount of rock salt over the ice, which is what turns it into a super cooling solution. Now we just chill out and wait. We need our bottles to reach -8 degrees Celsius or 17 degrees Fahrenheit, and then leave them chilling at that temperature for about 10 minutes. This whole thing, if you've refrigerated your bottles ahead of time, should take about ½ hour, but it's a great idea to keep your eye on it so you don't chill the bottles too much. Did you know that animals use supercooling as well? The Arctic ground squirrel has the lowest recorded body temperature for a mammal, which it achieves during its winter hibernation. The squirrel is able to eliminate all water from its system, which allows its blood to stay liquid during the winter. It goes to sleep until the summer comes back and it lowers its body temperature from 36 degrees Celsius to -3. 36 degrees Celsius is a good body temperature for a mammal like you or me, but -3 is enough to freeze water or stick your tongue to a metal pole. Ooh. That's cold enough that opening my fridge is going to feel like a trip to the beach. You're probably going to have to add some more ice and rock salt to your bowl as the experiment goes. But once you've observed the thermometer at -8 degrees Celsius for 10 minutes, the bottle should be at the perfect temperature. Don't get frustrated if this takes several attempts. It's actually a very specific temperature that the bottles need to be at for this to work. Science takes trial and error sometimes, and cooler heads prevail. Let's remove one of our bottles from the bowl. But you need to be very careful about this because if you knock it, the freezing process will start before you really get a chance to settle in to observe. So we're going to very delicately remove it from the bowl. As you can see, it's still liquid, but my thermometer was showing a reading of -8 Celsius for the last 10 minutes. So if everything's right, we should have the perfect temperature for this. And the last thing left to do is knock it down and it'll start that crystallization of ice. Nothing. Oh, it looked like it for a second, but it was just an optical illusion. All right. Nope, still very much liquid. And now, there's only one thing left to do. Nope. This experiment is known for having some trial and error associated with it. We've tried a few times here in the exploration station, and all we keep getting is super cold, refreshing water, which is great, but it's not quite the freezing process we were hoping to see happen right before our eyes.
Science!
Hey explorers, we need a take two. We made several attempts with those bottles over the day and we just couldn't get it to work. we found out that you actually had to hit the bottle a lot harder to force the heat energy out, which lets the crystallization process begin. If at first you don't succeed, try again. We've got a new set of bottles ready, and we're going to make another attempt. Oh, it worked! Yes! Oh, there we go. So like right down that bottle. Woo, it's still going. Oh yeah. Yes! Yes! Oh. Okay, we managed to do it. This took so many attempts because it's actually a very specific set of circumstances to get it done right. But we got it.
Yes!
Got our ice forming right in the bottle as we watched. Very cool.